Hello and welcome to the Learning Square. Today I will introduce you to Pandas, which is essentially a software library built in Python for data analysis. Before we talk about data analysis, we should understand what data sciences is all about. And data science is a multidisciplinary blend of technology, development of algorithms and data inferencing. So wherein we try to solve some analytically complex problems which we see in our daily lives. So there are various fields which are encompassed in data sciences. So we have something known as statistical inference, we have data extraction, wrangling and exploration. Then we have machine learning, classification techniques, unsupervised learning, recommendation engines, text mining, time series and deep learning. I will briefly go through all of them one by one in this lecture series. Now if we look around ourselves, we have data everywhere. Data from our government is available at data.gov.in. We have a lot of data sets available for downloading and for research purpose as well. Then the data set from WHO is available. Then we have datakind.org, which has lots of data sets to be downloaded free of cost. A very popular UCI machine learning repository is available for us with lots and lots of data sets which are commonly used. So data science is nothing new. We have always been studying data, we have always been looking at data, we have been doing statistical analysis. There's a term called artificial intelligence wherein we're trying to understand what this data is telling us and we're trying to build some predictive models. There's a term called business intelligence and then data analytics. So when you're simply shopping on Amazon, there are certain products which are kind of recommended based on your shopping trends. This is again artificial intelligence or machine learning. There's certain recommendations for the movie that you can watch. This is all based on your browsing history. And there's a model made for you individually which tries to predict what are you most likely to buy. Now once we have all this volume of data around us, let us see what are the steps that we should take to be able to understand that data and do proper data analysis. So data acquisition is the first step. I need to first collect the data which is relevant to me. So suppose a person wants to buy a flat. So what he does is he collects data from different locations and the price associated with that particular apartment. So the first field is the price, then the apartment name, number of bedrooms, floor number, criminal rate per year of the area around, pollution level of the area, distance to the nearby educational institution. Here you can easily understand that the apartment name and number will actually have no effect on the model that we are building because it really doesn't matter. The number of bedrooms, floor number, the rest of the other properties seem to have an effect on the price, so we will retain all of them. So my data acquisition. Data acquisition involves acquiring data from all the identified internal and external sources that can help us answer the business questions. So it could be logs from web servers, social media data, it could be census data, data streamed from online sources via APIs, it could be any data that I am acquiring. Now once I have this data, I know that the data will not be clean. There will be a lot of errors present. There may be some missing values, there could be data outliers. So I have to then wrangle the data or prepare the data. There may be also certain values which I just need to kind of modify from the existing value. So here the floor number is G. I know that the others are numbers, so maybe I could convert it into a 0 here. So I'll have to get them all in the same order here. If this is a numerical field, all the values should be numerical before I apply a model. This could be discarded. Then here the pollution number level is missing. So how do I deal with this? This could also be a question. Either I could just delete this entire row while preparing my model, or otherwise if I have a value of the of another apartment in the same area, then I could maybe copy it or maybe take an average of nearby around areas. This needs to be fixed before we actually move on to the modeling part. Now for educational institutions, I'll just, instead of taking the distance, what I do is I just change it to a boolean field wherein I just say whether the educational institution is within 1 kilometer radius or not. So I have a boolean value here. So data wrangling is the process of cleaning and unifying messy and complex data sets. I want them to be unified so that I'm able to apply statistics and modeling techniques on this. Then data after reformatting can be converted to a JSON, CSV, that is the comma separated values, or any other format to make them easy to load into any data science tool. So we will actually use Pandas to be able to load the CSV files here. Once this is done, then I need to actually build a mathematical formula depending on the values that I have. So I have certain numerical values here. So the number of bedrooms, the criminal rate and pollution, all these are numerical values. I'll feed them into a mathematical model and try to estimate the price. If I have a data set with 1000 values, then I would probably divide them into two parts. So I would have 70% for the training and 30% for the testing part. With the 70%, I will build a model here, and with this model I'll try to estimate for the 30% which is left with me. If my error for the price that I estimate is below the error that I'm okay with, then I'll go ahead with the model. Otherwise, what I'll do is I will again go ahead and change the model. So hypothesis and modeling involves forming and testing hypothesis around the data and the processes that generate it. So here suppose I have a model and I'm able to get a fair price estimation, maybe in a range of plus minus maybe 10,000 rupees, then my model is fair enough. The accuracy that you want for a model depends on the kind of precision you are okay with. So for medical problems, maybe you are not okay with even a 97% of an accuracy, but for other smaller problems, maybe trying to estimate the attendance of a particular student, trying to estimate the grades of a particular student, you could be okay with a 95% accuracy as well. After the model is made, like I said, we have a test set and I try to estimate the accuracy of this model. If the accuracy is low, then we again go back and keep repeating till a good model is found out. Once the model is up to my satisfaction, I deploy it for further use. So maybe I have an environment which supports only Java for a particular client, then I'll have to deploy the entire thing into that environment. We retrain the model with some new factors from the data set. So here maybe I had a model built for the price estimation of a particular place here for a flat. I could have certain new factors come in if I'm trying to look in for a educational institute in that same area. So I will look into that, be the population size of that area. So those kind of factors are put in, and then we again see if the model is accurate. If it is, we deploy it. Otherwise, we kind of again change the model a little bit. But we generally refrain from adding factors which may play a significant role in changing the accuracy of my model. So the typical steps are to import the data, prepare, explore and clean the data. Then you try to fit a statistical model. Then I try to evaluate using a 70-30 generally. I evaluate. If it is okay, I move ahead and evaluate the model prediction on the new data. So here the new data would be, suppose I have another flat come in. So maybe for the same area I have a 4-bedroom apartment. It should be able to estimate the cost, and I should be able to understand whether the price that I'm actually paying is as per the model that I made. So is it a fair evaluation or not? So then you actually predict on some new data and then you give your reports.